Hey guys, welcome back to Hustler's Algorithm. In this video, we would be solving this problem 2 sum 2 where the input array is sorted. We have another variant of this problem which is 2 sum where the input array is not sorted. So for now, let's look at this problem. So you can go through the problem statement to understand the problem. But what it says is we are given this array which is one based indexing and a target. So we have to find the indexes of two elements such that they sum up to this target. So let's understand this. So let's say we have this array as 2, then 7, then 11, and then 15. And the target is 9. Okay. So in the two sum problem, what we do is we iterate through the array and we will check if the target minus the element at every index, so the resultant, if that element is present in the array till which we have just traversed. So for 2 we have the target as 9, and so the 9 minus 2 which is 7. So till now do we have any 7? No, it's not present. So just move ahead. Now again, before moving ahead, we will put this 2 in the map. Now coming to 7, we do 9 minus 7 which is 2. So yeah, we have 2. So we can just return the indexes of these two because we will store index along with this. For one based indexing we can store just one. Okay, so this is an O of n approach but having space complexity as big of n as well. And here we are not utilizing the fact that the input array is sorted for this two sum problem. So what else we can do? So what we can do here is we can maintain two pointers, one which will be at this start position and another one which is at this very end position. So now we will check a couple of cases like the nums of this ith element plus the nums of this jth element. If this is equal to the target, if this is the case, then we can have something. Then another is if the nums of this ith position plus the nums of this jth position, if this is greater than the target, then again we will have a couple of conditions. And then if this nums of this ith element plus the nums of this jth element, is it less than the target? Okay, so we will check these three conditions, right? Okay, so let's shift this here. Now we will check if 2 plus 15, is it equal to target? No, it is much greater than this. Okay, so here it is much greater than the target. So what we can do is we can do here as j minus minus, which will shrink this pointer to the left side. Okay, so we have this j here now. Now again we can check if the ith position plus the jth position element, is it equal to target? So is it? No, it's greater than the target. So now again we will check if the element at this ith position plus the element at jth position, is it equal to target? No, it is again greater than the target. So we'll again shrink this pointer j, so the j will reach here. So now we can see that 7 plus 2, which is the element at ith position and jth position, it is equal to the target, right? So at this time we can just return the index of ith element and jth element in the form of the array. Okay, so this will give us the answer, right? Now here we will have another condition as if the sum of the elements at ith and jth position, if this is less than the actual target, then we can just increase the ith pointer so that it can go here. So yeah, this is it. So let's start coding this. Okay, so we will maintain two pointers, int I is equal to 0 and int j, which would be at the nums dot length -1, and this is the ending position. So we will traverse while I is less than j, right, while these pointers do not cross each other. Okay, so during this time we will check if nums of this ith element plus nums of this jth element, is it equal to the target? Is it? Then we can return just an integer array of size 2, which will have the answers as I and j. But again, here we will not return I and j because this is 0 based indexing and we want to return 1 based indexing. So we'll just add 1 here. Okay. Now the another condition is if the nums of ith element plus the nums of jth element, if this is greater than the target, then we can simply do j minus minus, else the another condition would be it is less than the target. So in this case we will do I plus plus. So yeah, this should return the answer. Now if no answer is present, we can just return an integer array. So it will have -1, which means we do not found any answer, right? So we will not reach this condition because here it is mentioned that we have exactly one solution, but for safety we have this. Okay, so let's run it. What's the error? Yeah, we should not maintain 2 here. Yeah, so we can just submit it. So yeah, it gets accepted. Thanks for watching. Subscribe to the channel for more such videos on data structures and algorithms.